So hi, everybody. So today we're going to talk about MySQL indexes and histograms and how we can speed up the queries. Right. Let's start by presenting a bit myself, so who I am. So my name is Frédéric Descamps, and as you can hear, I am speaking the most popular language in the world, which is bad English. So if there is something you don't understand, yeah, just you will have the slide later, read the slide, or just ask me after, and I will try to make it more clear. But usually my French accent, it's easy to understand. So my name, so it's Frédéric Descamps. I have a Twitter, which is Lefred, and this is also the nickname that everybody knows me from IRC and Slack, everywhere. It's Lefred in the MySQL community. So I'm a MySQL evangelist. I'm using MySQL since a lot of time. My first version, I remember, was 3.21. I am a DevOps believer, so if you have a question related to that, I can answer it later too. I like basketball. I'm living in Belgium, and I have a blog where you can find a lot of information related to MySQL, but not only, which is lefred.be. So what is this session about? So this session, it's about speed and performance, because nobody ever complains that the database is too fast. Usually it's the reverse, right? And they blame the database, even if it is not the database default, but this is how it works in the reality. And speeding up queries, it's not really a dark art, but understanding how to speed up those queries sometimes can be compared to magic, right? But we will see that it's not always the case. But there is some thing that you need to know to be able to do that, right? So we will be looking how to what is an index, how to properly use an index, what's an histogram, or to use it, and keep the right balance for your workload. Of course, this is a dry subject. There is a lot of content in my slides. So do not try to absorb everything I'm saying right now. Some slides I will even go very fast, review them very quickly with you, because like I said, we have a lot. But so today, don't try to absorb everything, but later you will get the slides, and please check them and read them. You will find and some stuff will be much easier to check when you see them for a second time. So what I won't cover today, but I can ask, if you have a question, I can answer them too also later. It's about system configuration, so related to OS or MySQL, the hardware, and networking in cloud. So this won't be part of this session. So query response time, the North Star. So here I will quote Daniel Nichter. So query response time is the only metric anyone truly cares about, because the query response time is the only metric we experience, right? When there is a query that takes 7.5 seconds to execute, we experience 7.5 seconds of impatience. And that same query might examine 1 million of rows, but we don't experience that million of rows, of course. It's just the time, because our time is precious. So this comes from Efficient MySQL Performance, Best Practices and Techniques from Daniel Nichter. I recommend you this book, but I will recommend you other books during the session. So, and this is so true what Daniel says here, because as a user, this is the response time that matters, right? So today on this session, the goal is to reduce the query response time. First thing, when we have a very large query response time, and if people blame the database, and you're sure that the database it's the problem, right? We need to find the ugly duckling. So what are bad queries? So we can define bad queries in two different categories. So the queries that are called way too often, for example, if you have one query that is called 15,000 times to just display one web page, this is way too much, right? But also the other queries are the queries that are way too slow, even if it's one query, but that same query takes I don't know, 1 minute, and every time you call it, it's 1 minute to wait for it, then it's way too long. And these tables that are way too slow, usually what they do full table scan, they use file sort, so they use sorting the result using a file, or they use temporary table, right? So this is just for the fun. Most of the time, full table scan, it's what scares MySQL DBAs. So if there could be only one query, right, and to optimize, and only one that you have to fix, right, this query, the best candidate will be the query that consumes the most of the execution time. And that execution time is the latency in the performance schema table that are also available in MySQL, right? So INSI schema also contain all the necessary data that we need to parse to find that bad query, right? So this is, for example, the query that you should execute to find the query you have in your system that consumes the most response time. This will be the first candidate of query optimization. So if we run that query on this system, or one system I was using for a conference several days ago, so we can see that this query was called only 5 times, but the total latency was 4 hours, 29 minutes, right? So with an average of 51 minutes per call. So this is the query I should optimize somehow, right? So the query previously provided you this information. As you can see here, we are looking information in performance schema to get that information and in schema. So schema also contains all required information to find very bad queries, like all the statements that do full table scans, all the statements that are taking most of the time, or the statement that do sorting and using temp tables. So you can find all these statements in performance and schema in MySQL. And since MySQL 8.0, we can also join with another table called performance schema event statement summary by digest to have exactly a sample of the query that you can use, because all the queries are in a form that are, it's a digest that you can use, and that, you know, they remove all the parameters and stuff. But if you want to have an example, you have it in MySQL 8. It's possible to have that. So we will check the meaning of all that in the other slide. Be patient. So first, one of the components of MySQL that is very important when we talk about queries is the optimizer, right? So the MySQL optimizer, it's considered as the brain and the system nervous of MySQL. So this is, every time we do a query, this is the component that decides what to do, right? So query optimization is of course part of many RDBMS, right? And in there also part of MySQL. So the query optimizer will attempt to always determine the most effective way to execute one query, and considering all the possible query plans we have. We're going to see later what does that mean in a few slides again. So, and this is the hardest problem in the query optimization. It's to accurately estimate the cost and all the possible plans. If you have one simple query, there might be only one plan. But if you have multi-tables, field columns in the work condition, this, you may have a lot of different plans that the optimizer needs to estimate to find the best one, right? And of course, the cost of this are some mathematical models, right, to find that query execution, and to make all estimation, because of course you don't execute the query. The optimizer won't execute all the query he will, or all the plans he is trying to find the best one. It's all done by estimation, right? We're going to see that in a few slides again, right? Of course, the goal of the optimizer is to get the data the cheapest way possible, right? And it's exactly like a route planner, right? You will have when you are in a route planner, we call it in Europe GPS, right? The cost, it's built on historical data, right? And this statistic can change while the optimizer is working. So like there is a traffic jam, you have the road, there is a new traffic jam. Oh, watch out, it's maybe too late to change road. So you have to go in that traffic jam, which means that you have made a poor decision, and the optimizer also can make poor decision. But of course, this is very, very rare, right? So don't worry that much about that, but it could happen, right? And this is why we need to check that, and we're going to see how we can check that, right? And so the final determination of the optimizer, it's called the query execution plan for the query, or what I call it also QEP, or the query plan. And of course, this is something, if you are an Oracle DBA, you must know that MySQL wants to optimize each time it sees a query. There is no something that where you can lock down the query plan like in Oracle, for example. So if you have a query that has 5 joins, for example, the optimizer may have to evaluate 120 different options, 5 factor, right? To find all the plans to get the best one to execute the query, right? So now we know what the optimizer is doing, and we know that at the end, when he checks all the query, it wants to find you the best query execution plan. And the query execution plan, we can also, as a MySQL DBA, check it and explain it's our best companion for that. So explain is the command that we're going to use as a DBA to obtain the query execution plan for a query, including information about how the tables are joined, in which order, which indexes are used, and the estimation, of course, that the optimizer do. So here on the right, you can see the help of the explain command, right? So let's run an explain on a query, right? This is a simple query. It is select star from city where country code equal GBR. And this is the query itself. Then we have the query plan. So we can see here the query plan and some extended information next to it. So for this query, what we can see that there is no partition. There is one table, which is city. There is some indexes. There is only one indexes that we can use, which is country code, and we are using country code. And we're going to return 81 rows for it. This is the query plan. But like I said, this is an estimation on how MySQL would run the query, because the query is not executed, right? So this is just how the optimizer would run the query. And as you can see here, the access type, right, is the ref here. You can see const, for example, right? It means that almost one row match for the table. But let's have a look here of all these access type. So this is a list, for example, of one of the slides. I won't go through it because, like I said, we have a lot. But this is information about all these and what it means. The thing as a DBA that we don't want to see, it's on the next slide. And here it is all full table scan. So when you see all, it is something you don't want to see, right? This is where the ghost was doing boo boo, and full table scan was ooh, scary. This is exactly where it's scary when you see this all as an access type. If you want to have examples of each access type, in the chapter 20 of Analyzing Queries from Jasper, you will find that, which is MySQL 8 Query Performance Tuning, April 2020. So this is another book I also encourage you to check if you are looking for query optimization in MySQL. So now let me show you another explain output with the join. So we can see here we have two rows. So we can see that we have it starts with the table country. Even if we start it, you see the query, we start the query with select star from city, join country. The optimizer decided to start with the table country, and he estimated to retrieve 239 rows doing a full table scan, and then it will join the table city, and where it also does a full table scan, right? And it used a hash join that we have in MySQL 8 to make. Before it was much more expensive to do that kind of queries. No, it's better, but of course, full table scan are not always recommended. If you are using MySQL Workbench, you can also have the explain in a visual output format, which is how it looks like. So these are just two examples of visual explain output. Finally, we have also another format, which is format tree. So if you are a DBA from another database than MySQL, you may be more familiar with this output, with the tree output, right? And so when you do explain format tree, you have a tree output like this one. This one was a short one. This one, it's a bit bigger, and I will show you even a longer one after. So this is how the output is, which it's more familiar for some people. And there is one last output, which is the most complete one, which is the JSON format. So when you do explain format JSON, you will have a lot of information about the query and the cost of it. And this is, of course, the most detailed estimation you can have. But again, this is, again, an estimation only, right? So can we know the real numbers? Of course, we can know some of the numbers, like if we run the query, we'll see how long it takes, but we won't have the statistics. In MySQL 8, it is possible to use explain analyze. With explain analyze, right, we use the output is the same as explain format tree, but we have the estimated cost, exactly was explain format tree, but we also have the actual executions and statistics. So we will have the time to return the first row, the time to return all the row, the number of row returned, and the number of loops. So these are not estimate anymore. These are the actual time. And we can see we have the estimation and then the actual time next to it, right? So this instrument, but also executes the query. So watch out, don't run explain analyze on a very, very large query that you expect to take hours, because you will have to, if you have to run it twice, one to analyze and then to run it, you will run it 2 times, and this may take a lot of time, right? So with explain analyze, this is an example, a bigger example of the output. You can see here is the actual time to get the first row. So the first row, it took 7 milliseconds, a bit more, to get it. Then here, the actual time to have all the rows. So it's 567 milliseconds. How many rows were read? So a bit more than 4,000 once, right? So this is how it works to get the information. So we run the query, but we also get all the instrumentation and statistics of it. So these are not any estimates anymore, as we can compare the estimate with the actual numbers. So if you're very interested in the explain, the MySQL manual has a lot of information about it too. Right. So this was for us to get the query execution plan, to know how to get it, and just to understand it a bit, how it works, right? So now we go in the indexes part. So find the rows with specific column value more quickly. This is the role of the index, right? So a database index is a data structure that improves the speed of the data to retrieve that. When we do a retrieval operation, we want to make it faster, we need to use an index, right? Of course, we need to pay a cost for it, and the additional cost is that we need to maintain that index by writing data into it, and also write it somewhere, which is the storage that we will consume to do that, right? Like I said, the indexes are used to quickly locate the data without having to search every time the full table for some data values, right? And indexes, this is important, can be created using one or more columns of a database table and providing a basis for both rapid random lookups and efficient access of ordered records. So this is exact the definition from Wikipedia that you can find here also. In MySQL, we support multiple kinds of indexes. So we have primary key that we can see as a clustered index, secondary index, full text index, and special index, right? So when you, on the right here, you see when we create an index, all the parameters and options we can have to create an index. So in MySQL, again, we have two types of index, B-trees index and hash index. And all indexes can have some, I call them properties, which is prefix of a column, multi-column, a unique index, a covering index, functional index, multi-value index. So this is all type of and properties for indexes that can improve you to find and to create the right index. So let's start with the most important in InnoDB, because if you don't know, InnoDB is a storage engine of MySQL by default, and the one you need to use, which is ACID compliant. If some of you are still using MyXAM, you should not, and use InnoDB. So each InnoDB table has a special index, which is called the clustered index, that stores raw data. Typically, the clustered index is the synonym of the primary key, right? So let's check now together an example of how mentally we could represent a table and an index usually. So not in InnoDB, but just how we can see where people think about a table and an index. So we have a table, table one, and an index next to it. So we insert a table, right? So this is, and we can see that the first column is the indexed column. So the key is 5001. So in the index, we put 5001. Then we add another column. So this is how we think it happened on the data, on the table. So 3, the new one, and the index gets sorted like this. Then another one, then another one, and then another one. This is how most of the time people represent a table in their mind, and that the index is pointing to the right one, right? In InnoDB, this is not how it works. In InnoDB, this is what we have. So when we insert into table one, and the value is 5001, and the first column is the primary key, this is how it works. So we have this, and that's it. Then we add another value. So in this case, again, we add the value which has the primary key 3. What happened? As you can see, the 3 on the table itself will be inserted before 5001, meaning that we need to move 5001 somewhere next after it. We enter 6. We need to add 6 after 3, and we need to move again 5001. Same for 27. Now we will add 12. What happens? We need to move 2 rows to be able to insert 12 here, right? So you can see this as a consequence, and we're going to see that in the next slides again, right? So this is the clustered index representation sorted by order of the primary key. So what we know now is that InnoDB stores the data in table space. And so far, we know that the records are stored and sorted using the clustered index. The primary key is the key for the index that is uniquely defined for a row and should be immutable. InnoDB needs a primary key. No null value are allowed. And this is important, is monotonically increased. You can see I was using integers and it was increasing. And if now you say, oh, but my primary key should be a UUID, you should use UUID to bin to be able to have a sequential one. If not, you should avoid UUIDs, and I will show you why. So what we don't know is that all secondary indexes in MySQL also contains the primary key at the rightmost part of the index. It's hidden, you don't see it, but it's there, even if you don't see it, right? So that means that when a secondary index is used to retrieve a record, two indexes lookup are done. One in the secondary index to find the primary key of the record you want, and then the one in the primary key to get the record. When there is no primary key defined in a DB table, what happens? Then the first unique not null key is used, and if there are none available, InnoDB will just create a hidden one, a hidden primary key that you don't have at all control of it, which is 6 bytes long. And the problem with such key is that you don't have control and that it is global for all the tables, InnoDB tables that don't have a primary key, meaning that if you insert in multiple tables, even if they are completely independent, you will have a mutex contention issue to find the next number of the primary key, which in MySQL you can see it as dix sys mutex. So you should avoid of not having InnoDB primary key, or let InnoDB create it for you. And another reason to have primary key is that for HA solutions, primary key are mandatory. So like I said, and like we saw when we were inserting the data in the primary key, the primary keys impact how the values are inserted and the size of the secondary index also. A non-sequential primary key can lead to many random IOPS because we need, if we add data always randomly and we need to move other data, what happens is that more and more you will see this. So this is a heat map of one table, and you can see that every time we insert data, everything is touched almost, right? Because there is not sequential, and so the InnoDB has to rebalance the clustered index, which is very bad. So this is something very bad to have for IOPS and operations to do. When we use a primary key that is sequential, like an auto-increment integer, then you can see that only the latest one are the ones that are touched, right? So this is why it's very important for performance here to use a sequential primary key. Now you can say, yes, of course, but my legacy application didn't define any primary key. And adding an auto-increment breaks the application because the application was not expecting this key there. So what can I do? Easy, just create a new invisible column and define it as a primary key. MySQL 8 allows you to do that. So this is one of these tables that has no primary key, right? Where you have a name and an age. So I call the table actors. Then, do we have a primary key? No. So let's find out by listing all tables which table don't have this primary key. So we can check in information schema and we can find, oh, look, Hollywood actors don't have any primary key defined. So this is one table that we need to fix. So now let's check the creation of that table. And what we can see in this table definition that indeed we haven't created any primary key. And there is no not null unique key either, right? So now we can add that hidden column as a primary key. So what we do, we will create an ID that is an integer, unsigned, auto-increment. I call it primary key, invisible, and first, right? So when I do, like my application was just doing select star from actors, we do that and we have exactly the same output, right? we can check now the table definition, and we can see that, oh, but there is a primary key, which has an invisible primary key. Great, right? But if I want to insert data without specifying the column, can I do that? Of course, you can do that. You can do insert into actors value, because usually it's always better and advisable to use the name of the columns when you add them. But if you don't, because your legacy application was not doing it, you can do it like exactly like this. And as you can see, it was added without any problem. But compared to the hidden, the auto-generated primary key by InnoDB, that is hidden in 6 bytes, where you don't have control and where it's shared between all the tables, here you have control of them, because if you want, you can say, oh, show me this table and show me the column, and you can see it. And when replication it's triggered, it uses this primary key also, right? So this primary key is sequential. It's used as a cluster index to store the data and also to externalize by replication. So if you don't have primary key, it is possible to create one in MySQL 8. Secondary indexes, what they are. So secondary index are other than the cluster index, but it's pointing to that primary index, right? And it always contains that primary key as the rightmost. This is why also we always advise to have the primary key very small, right? And oh, it's not search, but search. And we use this primary key to search in the cluster index, right? So if the primary key is very long, the secondary index will also be long. So how do we create that? We can create a secondary index on the prefix of a column if we want. So for example, here, I have name of the city. I can say, oh, I want to index only the 10th first characters, and to also save some space, but it's the 10 first characters are fast enough for me, even if they are instead of having one city that match the name I'm looking for, even if there are 3 of them matching the first 10 characters, I can then sort out of the 3. It's not a problem, right? So let's compare between the prefix index and an index using the full column, right? So you can see here, if I was creating an index on the name, we have the size here in bytes. And if I just use the 10 first characters, we can see that I reduce by 2 the size of my index, right? So now if I say, okay, this is one of the query I want to do. So I want to search the name, population from one city, and the name is San Chris, right? And there is at least 2 rows using having this name. You can see that the optimizer will go to using part of name, because that index will be faster to use, right? So we have the 2 indexes possible, but the short one will be used, even there are 2 candidates, right? Now, there is something strange here, is that 40. What does that 40 mean? Because I said, oh, we will index only the 10 first characters, if you remember, right? So the key length column indicates the length of the key that MySQL decides to use. Okay, but why 40 then? It doesn't make any sense, does it? In fact, we index the first 10 characters of the name column, but this use UTF-8 MB4 char set. This is the default in MySQL 8 for storing emojis, for example, and 1 character, it's encoded in up to 4 bytes. So 10 per 4 bytes equal 40 bytes, which is 40 bytes per record in the index, right? So this is why you saw 40. Now it is also possible to index multiple columns in one single index. So this is, we create an index, and we can, in the same index, index the first name and the last name column in one single index, right? So this index will work on first name, last name. So if we are looking for somebody where his first name equal a and last name equal B, we will use that index. If we say, oh, I want to find an employee where the first name is Fred, it will use that index. But if I say I want to find an employee where the last name equal Descamps, it won't work because it always starts from the left to the right, right? So let's have a look, right? Here, I do again, first name Fred, last name like dec and percent. We can see here, it used the key length, it's 124. And with the key length, I will be able to determine which part of that multipart index it's used, right? So for that, I need to check the definition of the table. The table is first name 14, last name 16, right? So 14, it's UTF-8 and before. So 14 per 4, 16 per 4, multiplied by 4. And you see, I always use +2 +2. Why that +2? Because it's a varchar, and the varchar's length is coded in 2 bytes. So it gives me 124. So meaning that for that query, both parts of that multiple index, so both columns were used. Now, if I say, oh, first name is Fred, only the first part is used because 14 multiplied by 4 plus 2 equal 58. So you need a bit mathematics to be able to do that. If I do this last name, just like dec, you can see that no indexes can use that because the leftmost part of the index cannot be used, so the index is not used. There is one, let's say, exception, right? What do you think about the two statements? They are almost the same, just the second one as ordered by. So which index will be used? None of the statement use an index. The left one will use the index, or the right one will use the index. And in fact, it's the right one that will use the index because of the order. We will do an index scan instead of a table scan to find that information. This is the only exception, right? Now, I will show you also another way to index information. So we need to rewrite a query, right, to be able to use that. But if we create a hash on a value of if we have large string, and we need to find the full data of the string, it's sometimes better to hash that value and index it, right? So here, for example, I said hash bin names. It's the hash of Amodeville, because I will concat the first name and the last name together. And you can see that if we do that, it will use that index, and the key length is shorter, and it will be much faster, right? I just forgot to skip this this slide, sorry. So this is how we create that index. So we generate an index of this hash bin name, which is the concatenation of the two. It's a virtual column where we index it, and it gives us the possibility to make it much faster. So MySQL supports functional key parts that index. So these are just expressions that we can use to index data using MySQL functions, right? So for example, let's have a look at this. So we want to find the first name, the hire date from an employee, where the month of the hire date is 3, March, right? So we can get the execution plan, and you can see that to get that information, we need to do a full table scan, right? So we do that, and we can see that he has almost 300,000 rows that he needs to parse. It's a full table scan, what we don't like in MySQL. But we can create a month hire index on the employee, and here, mind the double parentheses, we can just create the index using the month function. And now, when we do this, we will use that new index we created, which is a functional index, right? So it is very, very important, nice to be able to do this kind of index too in MySQL. Something to keep in mind is that if there is a choice of multiple index, MySQL will use the index that finds the smallest number of rows and the most selective one, right? Of course, if the MySQL, if you for joins and stuff, it will be better if you join on two tables if you declare the two columns you join the same type and size. When you have a null value in an index, right, it will really drive down the performance of that index. So pay attention of that because it's very important. Null means there is no data. It's a lack of data. So it's not true or false. It's you don't know. MySQL offers you also the possibility to hide indexes from the optimizer. And this is very useful for operators that needs to operate MySQL in production, right? Because before the invisible index, you had, okay, I think this index is not useful. I will remove the index. And then somebody calls you, scream on you about the slow performance. You need to recreate that index, and it can take a long time, of course. With invisible index, you think the index is not useful, you can make it invisible, so optimizer won't use it, but it will keep updating it. So if somebody calls you and says, oh, there is a big issue here, it's slow, you make the index visible again, and then you just blame a networking problem or something like that, and your DBA job, it's easy and cool, right? So invisible index are very useful for this. This is how we do, we put an index invisible or visible. We can also find all the invisible index we have in the database. So something very important for the DBA, it's that unused index are expensive because every time we modify data, we need to update that index. So if you can get rid of the index you never use, it's better to remove them. And Syschema provide you the information to find that. So here you will find the size and the index that we never use. We never use since the start of the MySQL. So meaning that if you have restarted MySQL recently, it's only since 1 or 2 days, not since it's working. So always be careful when you remove an index, make it invisible first, wait a bit, check, and then remove it, because maybe your index is used only once a month, right? And it's exactly the same for duplicate index. So sometimes you have several indexes, the same indexes or different indexes, meaning that they are indexing the same data. And this is no need to keep them and to maintain them. So in Syschema, you have also that information. And for example, here you can see that there are duplicate indexes. So for example, the part of the name we did earlier and the name are two indexes that can be duplicated. Of course, do not take the recommendation at face value and check before deleting them, like I said, right? Because this is very important to know that. So now, let me see here. When I remove an index, can I estimate the time left, right? So yes, it is possible. So this is a query you will copy paste, and this is how you get that information. So we can see how many % is done, how many time it takes and stuff. I am running out of time. I am sorry, even if there is nobody after me. I want to just show you histograms in MySQL. You have also the possibility in MySQL to have histogram when you are not able to create indexes. You have two types of histogram, statement and optimizer. The optimizer histograms is the one that are important for you. Statement histograms, I'll let you check what it means. There is no more information about that. But optimizer histogram, it's when you are not able to create indexes because there is way too much value, MySQL has the possibility to create an histogram. Just wanted to show you here. For example, I have this query where I want the first name to be Crucio and the length of the movie has to be less than 55 minutes. It will return me 6 rows. And this is the query execution plan of it, right? If I create histograms, so this is how we create histograms. I will create 256 buckets on the length. And if I do that, it won't do anymore. It will just do a full index scan and not the full table scan anymore to find that. And you can see that the query is much faster now, right? MySQL allows you to find information about which table have histograms and which are these histograms and how they are created and how you can find them, right? This, I will let you see just example of how to use histograms. I will let you check that in the slides after the talk. You can have it, but you can see that it's much more precise. And to finish, I want to show you this. In the OCI, if you think your query, even if you're doing good indexes, if you are doing good histograms, it's still too slow, right? You can enable an analytic engines that allow you to make it much faster, right? So this is a query. You can say it takes 1.2 seconds. When I enable each wave, it is 10 times faster, right? So much, much faster. And for example, you can see where you have much more data, it's much more faster, right? So this is something very, very nice. So I want to talk about this. You will have in the slides. Just some books if you're interested. So these are MySQL books that are new books on MySQL 8. So I really recommend you to read them. And share your love to MySQL, and I will be able to answer your question. I was a bit longer, sorry, than expected. So I will answer your question if you have questions now. The slides will be available, like I said, on SlideShare soon too.
Frederick, thank you so much for your talk today. If anyone has any questions, we do have a few minutes since you're ending the day. It looks like you're getting applause here. Everyone is enjoying your talk.
Thank you. Yeah, well, a bit sorry that there are 2 or 3 slides. I was a bit fast on it, but people will have the slides and they can use it as a reference, right? So this is why I wanted to add data into it.
And I know you put the links to your slides at some point. I'm not sure how long it will take Open Source 101 to get the videos kind of segmented into each talk and get them online, but eventually they'll be online and shared out. So I guess pay attention to the Open Source 101 website and you know, to look forward to all the talks and stuff. But I will also email everybody that was on my track as soon as I know that they're out. So I'll email you all. But thanks again so much for being part of Open Source 101, for ending the day on such a great note. So much information. There's so much to dig into. And you shared a wealth of wisdom with us today. And we look forward to having you back at some point, and hopefully our paths will cross, and keep educating and imparting your wisdom on everyone. So thank you so much. And thank you to everyone who has attended today. And thank you to DataStax for sponsoring this track today. And I hope that you all have a great day. And up next, in about, I guess, 15 minutes or so, will be the ending talk for Open Source 101. So thank you so much, and pop over there and watch that ending talk.
Thank you. Bye-bye.